अस्सलाम वालेकुम जी, क्या हाल है? ठीक ठाक।
वालेकुम सलाम अल्हम्दुलिल्लाह सर।
जी, क्विज कैसे हुआ था? ओके जी। सो टुडे वी आर स्टार्टिंग 11th lecture of this after midterm examination. Uh, the topic of this lecture is the Laplace transformation. So why Laplace transforms? So if you remember, the differential equation solution contains two parts. That is, if this is y double dash plus 3y dash plus 2y, this is equal to 0, suppose, or this is equal to some function ex. So the solution of this differential equation contains two parts. One is the complementary solution, that is yc, and another is the particular solution, that is yp. So the sum of these two solutions gives you a general solution. This is y. And if you have some initial condition with this problem, that is y of 0 is equal to 1 and y dash of 0 equal to suppose 0 or minus 1. So you get, if you put these values in this solution, so yc contains two arbitrary constant, if you remember. So if you put these initial condition in this y, so you will get a specific solution for y, specific solution. So this y is actually the general solution. The general solution contains two parts. One is complementary solution, another is particular solution. But if you put the initial condition, so you will find the arbitrary constant of integral c1, c2. After putting these c1, c2 in this general solution y, you will get a specific solution for this specific problem. जी समझ आ रहा है? हेलो.
Yes sir, yes sir. We'll
Okay.
begin sir.
Okay, ji. So in Laplace transform, we are not defined it yet. Like due to Laplace transform, actually we are solving the differential equation. Laplace transform की मदद से हम differential equation solve करते हैं and Laplace transform. So let's first define the Laplace transform. What is Laplace transform? Why Laplace transform? So before why Laplace transform, let's define a Laplace transform. So if you have a function f of t, suppose, if you have a function f of t that is defined, which is defined for all t is greater or equal to 0. So if you multiply this f of t with e power minus st, e power minus st is a function, exponential function, and integrate this from 0 to infinity, and integrate this product from 0 to infinity with respect to t, so you will obtain the Laplace. Laplace is denoted by this notation, Laplace of f of t. So if you want to convert, what is meant by transformation? So transformation means जिस तरह आप डेरिवेटिव पढ़ते हैं, if you differentiate a function d by dx sine of x, so as a result you will obtain cos of x. So the behavior of sine x is different, but the behavior of cos x, the behavior of sine and cos are different from each other. So this derivative actually change the behavior of this sine to cos x. So this is called transformation. Transformation means if you apply some operator on a function and this function change and this function change its behavior, so the operator, yeah, the process due to which a function change its behavior is known as transformation. इसी तरह अगर आप इंटीग्रल ले लें, so integral of sin x is minus cos x. So again integral change the behavior of sine to minus cos x. So it means minus cos x plus constant of integral plus c. So integral is also a transformation. So transformation means if you apply some operator on a function and this operator, if this operator changes its behavior, so this operator is known as the transformation. If you take heat from water, so heat from water, so it will convert to ice. So heat is a transformation because it changed water into ice. The properties of ice is different, but the properties of water is different. It means the behavior is changed to ice. The behavior of water changed to ice. It means heat changed the behavior of water into ice. It means heat is a transformation. So transformation means if it change its the behavior of a material, if it change the behavior of a function, so this is called a transformation. So Laplace transformation is also a transformation which defined by Laplace. So therefore this transformation is known as the Laplace transformation. सो अगर कोई ऑपरेटर किसी फंक्शन के बिहेवियर को चेंज करे, सो द बिहेवियर द ऑपरेटर इज नोन एज द ट्रांसफॉर्मेशन. सो लेप्लास ने भी उस तरह डिफाइन किया था. लेप्लास डिफाइंड दैट f of t is a function and that function is defined for all non-negative values, so that function can be convertible to Laplace. सो हर एक फंक्शन लेप्लास ट्रांसफॉर्म से ट्रांसफॉर्म नहीं होगा. That function will be transformed using the Laplace transform if it is defined for all non-negative values. This is first thing. You will see that if this function is defined for all non-negative real numbers, so that function can be converted to another function by using the Laplace transform. So Laplace says that if you multiply that function which you want to convert, जिस फंक्शन को आप कन्वर्ट करना चाहते हैं, you multiply that function with an exponential function e power minus st and integrate the product of these two functions from 0 to infinity, you will get another function which will be a function of s, and that function of s is actually the transformed function. Suppose if I take 0 to 1 x plus y into d of x, so the integral of this will be equal to x square by 2 plus x and y and 0 to 1. So if you apply this limit, when you put x is equal to 1, so you will get 1 by 2. If you put x is equal to 1, so you will get 1 multiplied by y, which is y. So if you put x is equal to 0, so this term will become 0. And this is the result, 1 by 2 plus y. 1 by 2 plus y can be written as a function of y. So if you integrate a function which is dependent on x, y, and you are integrating with respect to x, so this limit will also for x, 0 to 1 is for x. So this x will remove due to this limit. So the function will become a function of y. So अगर आप दो multiple function two variable पे कोई function, if you are integrating a function which is dependent on two variables and you are integrating with respect to one variable, so that variable will disappear and the function as a result will become the function of another variable. ये समझ में आ रहा है जी?
Yes, sir.
Okay, ji. So similar is the case here. If you are integrating, now this function is dependent on t and s also. So this is dependent on s. The product is actually dependent on s and t. So if you are integrating with respect to t, and this limit is from 0 to infinity is for t, so this t will disappear and the resultant function will become a function of s. So Laplace of f of t is actually f of s. ये आपको एक फंक्शन ऑफ s देगा एंड फंक्शन ऑफ s कब मिलेगा? It will result if you integrate the product of f of t with e power minus st with respect to t. So this is the definition of Laplace transform. So you can define your own transformation, but there are some properties of transformation. So properties of transformation is, if you are defining a transformation, so you can define this transformation. Suppose if I multiply f of t with t square, suppose I am defining this transformation from 0 to 2. Suppose this is suppose I am giving the name to this transformation, that is the onward transformation. Suppose so this is the product. If you want to transform f of t into onward transformation, so you multiply it with t square. So let's see that this is defined transformation or not. ये उन्होंने जो डेवलप किया है ये एक डिफाइंड ट्रांसफॉर्मेशन है. व्हाई दिस इज डिफाइंड एंड व्हाई दिस इज नॉट डिफाइंड. हर एक ट्रांसफॉर्मेशन का एक इनवर्स ट्रांसफॉर्म भी एग्जिस्ट होना चाहिए. सो इफ देयर एग्जिस्ट द इनवर्स ट्रांसफॉर्म, so that transformation is defined. So if you define it in this way, so the inverse transform will not exist. It means that you cannot define the inverse transformation. समझ आ रही जी? जी
Yes, sir.
ओके जी. जिस तरह आप डेरिवेटिव डिफाइन करते हैं, सो द इनवर्स ऑफ दैट इज द इंटीग्रल. Integral, you are defining integral, so the inverse is the derivative. So similarly, there exists the inverse Laplace transform of what? Of the Laplace transform. So for each transformation, if there exists some inverse Laplace transform, so you can define their transform and you can give the value to their transform. So Laplace defined this transformation And due to this transformation, he also derived formulas for transforming some different functions. जिस तरह आपने sin के लिए फार्मूला डेवलप किया था डेरिवेटिव के लिए using the ab initio method, if you remember. So the derivative of sin x is cos x if you are using the ab initio method. Similarly, derivative of x square is 2x if you are using the ab initio method. So the process from which you are deriving formulas are called transformation. So similarly, Laplace transform is defined in this way. If you are applying Laplace on some function, so that function must be defined for all t is greater or equal to 0. And if you want to transform that function, you multiply it with e power minus st. If this integral exists, second thing is this one, if this exists, अगर ये एग्जिस्ट ही ना करे तो फिर उस फंक्शन का लेप्लास ट्रांसफॉर्म एग्जिस्ट नहीं करेगा. इफ दिस एग्जिस्ट, इफ दिस इंटीग्रल एग्जिस्ट. So there are two things for transforming a function using Laplace transform. First thing is that function must be defined for all t is greater or equal to 0. And second thing is this integral, that is the product of exponential function and the function which you want to convert it. If the product of these two functions, if the integral of the product of these two functions exists, so you can convert this f of t into Laplace transformation. Suppose if you want a function f of t is equal to 1 over t, so this t is actually not defined at t is equal to 0. So you cannot convert this function into Laplace transform. आप इसका Laplace transform find नहीं कर सकते because this function is not defined at t is equal to 0. G, you cannot define the Laplace transform of 1 over 1 minus t because this is not defined at t is equal to 1. But if you take t square, t cube, t, so all these are now defined for all t is greater or equal to 0. So it means you can define the Laplace transform for t square t, and e power t is also defined for t is greater or equal to 0. G, sin x is also defined for t is greater or equal to 0, sin t. Cos t is also defined for all t is greater or equal to 0. So you can find the Laplace transform of such functions which are defined for all t is greater or equal to 0. So if a function is defined for all t is greater or equal to 0, so you can find the Laplace transform for that function. But another condition is where this function fails to transform it, if the product of these two functions, if the integral of the product of these two functions exists, so the Laplace transform will exist. Otherwise, the Laplace transform will not exist. G. समझ में आ रहे हैं?
Yeah.
Any question about this? Okay जी.
Yes, sir. The last
So
this
and
this
what?
formula,
जी जी.
sir. This formula transform Laplace formula. Can you repeat again its explanation?
Uh, I am not hearing you correctly. So if another student explain this question, I will be able to explain your the answer of this question. G. Any student understand the question of Ibrahim? G, can you repeat Ibrahim your question?
Yes, sir. I said, can you repeat again the formula of transform Laplace?
Okay. Uh, suppose you want to transform t square using the Laplace transform. So you multiply t square with e power minus st and integrate the product of these two from 0 to infinity. As a result, you will obtain a function from this integral. That, that function which you obtain from this integral is known as the Laplace transform of this function. So Laplace transform of t square, Laplace transform of t square is actually equal to t square multiplied by e power minus st dt from 0 to infinity. So as a result, when you obtain a function, मैं यहाँ पे कह रहा हूँ if I obtain 2 और s क्यूब यही आएगा, लेकिन मैं आपको बाद में बताऊंगा कि how it is appeared. So the product of these two functions, the integral of the product of these two functions is this one. So Laplace of t square is actually this one. Okay. So if you want to convert a function to Laplace transform, first thing is you check that function that it is defined for all t is greater or equal to 0 or not. Then multiply this function with e power minus st and integrate from 0 to infinity. If this integral exists, so the value of this integral is known as the Laplace transform of this function f of t, g. Now is it okay? Okay, G. So what is inverse Laplace transform? Inverse Laplace transform. Inverse Laplace transform. So if you apply the L inverse on both sides, so you will get L inverse L of ft which is equal to L inverse of f of s. So the L and L inverse will cancel each other and you will obtain f of t. This is equal to L inverse of
Hello,
J. Hello?
is everything fine?
So this is the inverse Laplace transform of f of s. The inverse Laplace transform of f of s is actually again the same function f of t. जिस फंक्शन को आपने लेप्लास ट्रांसफॉर्म लिया था, अगर उस जो उसका रिजल्ट था वो f of s था. F of s is what? F of s is the result of the f of t after transforming it. So if you take the inverse transform of this function f of s, so you will get the original function f of t. So this is simple thing. When you perform the calculation, so it will be clear more. So थोड़ी सी हम थ्योरी पढ़ते हैं. स्लाइड से ऑलरेडी मैं ये चीज़ें एक्सप्लेन कर भी चुका हूँ. So the process of solving an ODE using the Laplace transform method consists of 3 steps. The given ODE is transformed into algebraic equation. So if you are solving differential equation using the Laplace transform, so actually the Laplace transform convert the differential equation into algebraic equation. Remember this point. The Laplace transform actually convert the differential equation into algebraic equation. So if you solve that algebraic equation, so actually you will solve the given ODE. So the solution in step 2 is transform back resulting in solution of the given problem. So ये जो 3 steps हैं when you start the differential equation, So automatically these three steps will be clear. So the key motivation for learning about Laplace transform is that the process of solving ODE is simplified to an algebraic problem. So the key motivation for learning about Laplace transform is what? It actually transforms the ODE to algebraic equation, and you better know about algebraic equation. You can better handle the algebraic equation. So algebraic equation के साथ डील करना डिफरेंशियल इक्वेशन की बनस्बत थोड़ा सा सिंपल है. So actually you convert the differential equation into algebraic equation, and then you deal with algebraic equation for solving that algebraic equation. And so the Laplace transform, the motivation for learning this Laplace transform is because the Laplace transform transform the ODE to algebraic equation. G. लेकिन ये इसका बाद में पता चलेगा when you apply the Laplace transform on a differential equation, so you will see that it will convert it into algebraic equation. So this type of mathematics converts problem of calculus to algebraic equation. So the Laplace transform actually convert the problem of calculus. Calculus means change, derivative, या the problem of differential equation आप कह सकते हैं to algebraic equation. So the Laplace transform has two main advantages over the other methods which we have studied in chapter 1 and 4. 1 to 4. प्रीवियसली हमने जो मेथड्स पढ़े हैं लेप्लास ट्रांसफॉर्म को दो एडवांटेजेस उन मेथड्स पे हासिल हैं. कौन कौन से? So there are two advantages of Laplace transform over the other methods which we have studied already in 4 chapters. First advantage is in other methods. So you are solving actually a differential equation. So another method, first you find yc, then you will find yp, and then you will add these two solutions and you will get a general solution. Then for particular solution, you will put the initial condition and you find the constant of integral, and you will get the specific solution if you remember. But in Laplace transform, you are directly finding the solution without finding the general solution. इस उसमें previous methods actually you first find the general solution. For general solution, you first solve the homogeneous part, then you will find the particular solution, then you will add these two for finding the general solution. But in Laplace transform, we will not find the general solution. We will find directly the specific solution. So this is the advantage. So the calculation in the Laplace transform as compared to the other methods is very less. So computationally ये expensive नहीं है. Laplace transform is easy than the other methods which we have already studied in previous chapters. G. Is it clear? This point is clear now?
Yes, sir.
Okay, G. More importantly, the use of the unit step function या heaviside function, direct delta functions make the method powerful. So आपने ये पढ़ा होगा if this is a step function suppose. So हमने previous methods में इस टाइप के फंक्शन के डिफरेंशियल इक्वेशंस के बारे में नहीं पढ़ा था. So here you can also handle the step functions using the Laplace transform, जो कि previous method से आप handle नहीं कर सकते थे. So what is the definition? If f of t is defined for all t is greater or equal to 0, so जिस तरह मैंने पहले कहा, and if you multiply f of t with e power minus st and integrate from 0 to infinity, so it is said Laplace of f of t is equal to 0 to infinity e power minus ft dt, and the result is f of s. So if this integral exists, so this is called the Laplace transform of the function f of t. ऑलरेडी हम पढ़ चुके हैं. सो हम अब कुछ फार्मूले डेवलप करते हैं. Let's see to develop a formulas for finding the Laplace transform. So if the question is question is let f of t is equal to 1, suppose. Find Laplace transform of f of t. This is the question. Solution. So actually we are new with this topic, so we are first studied the basic of this topic. जिस तरह हम डेरिवेटिव के बेसिक्स को हमने पढ़ा था कि what is the derivative of 1, what is the derivative of x, what is the derivative of sin x. So you have derived the derivatives of this function from your basic definition of derivative. That is the ab initio method, if you remember. So to start the Laplace, we will use the definition of Laplace, and you will develop some formulas from that definition. So as we know that is Laplace transform of any function f of t, but not any function, any function which is defined for all t is greater or equal to 0, it will be equal to the integral of the product of the two functions. One is f of t and another is e power minus st. So if you multiply these two functions and integrate from 0 to infinity. अच्छा, एक बात नोट करें, the original function is dependent on t, but after transforming you will obtain a function of s. So the new function, the transform function, will depend on s. So what is f of t in this case? Now f of t is 1. F of t is 1. So if you put f of t is equal to 1 instead of f of t, so you will obtain 1 into e power minus st, because f of t is 1. Now you integrate e power minus st with respect to t, so you will obtain e power minus st divided by minus s, and this is 0 to infinity. So if you apply this infinity, so you will get e power minus infinity divided by minus s, and if you apply this lower limit, so this minus will become plus, because if you apply the lower limit, you will also put minus. So minus minus will give you positive value. So this is e power minus 0 divided by s. Is it clear? G.
Yes, sir.
So, okay, G. What is e power minus
Yes,
infinity? What is e power minus infinity?
sir.
E power, G. What is e power minus infinity? E power minus infinity is 1 over e power infinity, and 1 over e power infinity is 1 over infinity, and 1 over infinity tends to 0. So this term will shift to 0. So this will give you 0, and e power 0 will give you 1. So this is 1 over s. So Laplace transform of 1 is 1 over s. Remember this. This is 1 over s. So now what? आप जिस तरह 1 का डेरिवेटिव लेते थे कि डेरिवेटिव ऑफ 1 is 0. So now the Laplace transform of 1 is 1 over s. Remember this value. The Laplace transform of 1 is 1 over s now. Is it clear?
Yes, sir.
Okay. So this is new formula. If you are transforming 1, so you will write 1 over s directly. So if you put this 1 is equal to 2, so this will become 2, and this will become 2, and this will become 2 multiplied by these two functions, and this will become 2 multiplied by 0 plus 1 over s, and this will become 2 over s. Is it clear?
Yes, sir.
Okay, ji. So if you write this is a, this is a, this is a is any real number, this is a, so this will become a by s. So Laplace of a, where a is any constant value. So now write this formula that Laplace of a any real number is equal to a by s. सो ऑल कांस्टेंट को हम अब लेप्लास ट्रांसफॉर्म से कन्वर्ट कर सकते हैं. सो लेप्लास ऑफ 2 is 2 over s, लेप्लास ऑफ 3 is 3 over s, लेप्लास ऑफ 10 is 10 over s. So now you can convert any function, any constant function by Laplace transform. Now if you have f of t is equal to what? F of t is equal to t. Now we are converting polynomials. This is suppose t. So if you put the value of f of t is t, so you will get 0 to infinity. What is f of t? F of t is t. This will become e power minus st into d of t, which is equal to g. You will perform integrating by parts. What is integrating by parts? You will write t and you will integrate e power minus st divided by minus s. If you remember, you will write again minus, you will put the limit first, because there is a limit. Then you will write the minus 0 to infinity, the derivative of this t, which is 1, and the integral of the second function, e power minus st divided by minus s into d of t. This is actually integrating by parts. So if you put t infinity here instead of t, so this will become e power minus infinity, and e power minus infinity is 0, so this will give you 0. If you put this 0 and this t, so again this will give you 0. Plus this is minus, this is minus, so if you take this 1 over s common, because this is constant for this integral, so you will get 0 to infinity e power minus st into d of t. Now this is 1 over s, but the integral of e power minus st is again e power minus st divided by minus s. So if you put this limit is 0 to infinity. So again, if you put infinity, so this will give you 0, because it will become e power minus infinity, and e power minus infinity is 0. So if you put 0, so if you are putting 0, so this minus will become plus, and this is e power 0, so 1 over s ban jayega, and this is what? 1 over s square. Is it clear? J. So note this point that Laplace of t is 1 over s square. जिस तरह डेरिवेटिव ऑफ टी 1 था, अब लेप्लास ट्रांसफॉर्म उसका 1 ओवर एस स्क्वायर होगा. दिस इज 1 ओवर एस स्क्वायर. इज इट क्लियर?
Sir.
Okay ji. So if you put this f of t is equal to t square, so this will become t square, this will become t square, and now this will become t square, and this will become what? This one will become what? जी कौन बता सकता है? This will become 2t. Is it clear? जी.
Yes, sir.
Okay. So what is this? If you take common this 2 or s, 2 or s, so this will give you t into e power minus st. So what is t into e power minus st? This is Laplace of t actually. This is Laplace of t. If you take common this 2 or s, so you will get t e power minus st and 0 to infinity. But this is Laplace of t. So this is 2 over s. But what is Laplace of t? Now the formula you have derived the formula for Laplace of t, which is 1 over s square. So what is this? This will give you 2 by s cube. So Laplace of t square is 2 by s square. So write this formula. Laplace of t square is now 2 by s square. Sorry, 2 by s cube. If you put this f of t is equal to t cube, this is t cube, this is t cube. So this will become t cube, and this will become what? G.
3 t square.
Yes, this will become 3t square. This will become 3t square. So if you take common this 3 over s, so minus minus will become plus. So this 2 over s will become 3 over s, and the remaining result will become what? Laplace of t square. But Laplace of this is 3 by s. But Laplace of t square is what? This is 2 by s cube. So this will become 3 multiplied by 2 is 6. 6 divided by s power 4. Is it clear?
Yes, sir.
So this will become what? 3 factorial means. 6 factorial means 3 factorial. You can write it. Divided by what? S power 4. So what is this? Note this point. Now I am generalizing this formula. What is Laplace of t? 1 over s square. You can write this 1 over s square as 1 factorial into s square. Laplace of t is what? T square. This is 2. 2 means 2 factorial. Divided by what? S cube. S cube means 2 plus 1. This 2 means 1 plus 1. Is it clear? Laplace of t cube is what? G. 3 factorial divided by what? S
S
power
for
4.
S for
Yes, S power 4 means 3 plus 1. So if you see the pattern of the Laplace transform of the polynomials, so you can write this if you generalize it. So Laplace of t power n, now n is any power, so this must be n factorial divided by s power what?
n plus 1.
Yes, n plus 1. सो अभी हमें बाकी फार्मूले लिखने की ज़रूरत नहीं है, टी के लिखने की ज़रूरत नहीं है. आई एम राइटिंग दिस this these only these two formulas, because now this is a general formula and I can derive the other formulas from this. So this is Laplace of t power n, which is equal to n factorial divided by s power n plus 1. So this is the formula for transforming the polynomial. So if you want to derive the Laplace transform of t, so put n is equal to 1. So this will become 1 factorial means 1 divided by s square. If you want to derive the formula for Laplace of t square, you will put n is equal to 2. So 2 factorial divided by s cube. So similarly you can derive the other formulas. सो अब हमने कांस्टेंट के लिए लेप्लास ट्रांसफॉर्म का फार्मूला डेवलप कर लिया, पॉलिनोमियल के लिए हमने डेवलप कर लिया. नाउ वी वांट टू डिराइव द फार्मूला फॉर लेप्लास ट्रांसफॉर्म व्हेन f of t is exponential function. When f of t is exponential function, so suppose this f of t is what? This is e power at. Now a is, maybe a is 1, maybe a is 2, maybe a is 3, maybe a is 1 by 2. So a is a general coefficient of t. So e power at means suppose e power 3t. So what is the Laplace transform of e power 3t? So a is general value. How to transform it? So Laplace transform of e power at, this is equal to g 0 to infinity. Instead of f of t, you put e power at, because now f of t is e power at, but e power minus st is already here, e power minus st into d of t. So if you multiply these two exponential functions, so you will get 0 to infinity e power g a minus s into t and d of t. Is it clear? This is simple calculation.
yes,
Yes,
sir.
sir.
Okay, ji. So if you integrate this, you will get e power a minus s into t divided by a minus s, and what? 0 to infinity. Okay जी. Now आप मुझे बता दें कि ये इंटीग्रल कब एग्जिस्ट करेगा. जी.
If a is not equal to
When a minus s is less than 0. सोच ले इस पे थोड़ा सा. When a minus s, when the coefficient of t, which is in power of e, when the coefficient of t is less than 0, so the if you put if you put infinity instead of t, so this will become e power minus infinity, and e power minus infinity will become 0. But if a minus s is positive, so this will become e power positive infinity. E power positive infinity means e power infinity. E power positive infinity means infinity. So this integral will not exist then. So a minus s अगर नेगेटिव हुआ, ये इंटेग्रल एग्जिस्ट करेगा, लेकिन अगर ये पॉजिटिव हुआ, ये इंटेग्रल एग्जिस्ट ही नहीं करेगा. जी, is it clear?
Yes, sir.
Okay, G. So if a minus s, so let impose a condition, because for some values of if a minus s is less than 0, so this integral exists. But if a minus s is greater than 0, this integral does not exist. So let impose a condition, because under some condition this integral exists, and under some condition this integral does not exist. So let's separate these conditions and find a formula for this function e power at. G. So I am imposing a condition, let a minus s is less than 0. Let a minus s is less than 0. Then this will become what? E power minus infinity divided by a minus s. And this will become minus e power 0 minus 0 divided by a minus s. Is it clear? So this will become 0, and this will become 1 over what? If you take common minus from this s, so this will become s minus a. So Laplace transform of e power at, this is equal to 1 over s minus a. But this is under some condition. What is this? What is that condition? If a minus s is less than 0, it means what? Minus s is less than minus a. Yeah, s is greater than a. So s is greater than a. So this formula is derived under this condition when s is greater than a. G. Is it clear?
Yes, sir.
Okay. So now we have derived three formulas. I am writing it again ताकि आपको ये याद रखने में आसानी हो. First is Laplace transform of constant, that is a over s. Second is Laplace transform of what? T power n. T power n. This is equal to what? N factorial divided by s power n plus 1. Third is Laplace transform of e power at. This is equal to 1 over s minus a. But this is under some condition that s will be greater than a. So this is third formula. Now, if you, what will be the Laplace transform of e power 2t? जी ये बता दें, Laplace transform of e power 2t क्या होगा? 1 over s minus 2.
1
Yes,
over s minus 2.
yes, yes. So this is the Laplace transform of e power 2t. Now, if this e power at is equal to cos hyperbolic at, then find Laplace transform of f of t. Cos hyperbolic at, g, Laplace transform of cos hyperbolic at. So you will write 0 to infinity cos hyperbolic at multiplied by e power minus st into d of t. So what is the cos hyperbolic at? If you remember, cos hyperbolic at is e power at plus e power minus at divided by 2 factorial means 2 e power minus st. ये याद है ये फार्मूला?
Yes, sir.
Okay जी. So if you multiply this 0 to infinity, 1 over 2 is common here. So this is 0 to infinity. E power at multiplied by e power minus st. This will give you e power a minus s into t. And plus e power minus a plus s into t if you multiply the second term with e power minus st. So this one, this is the, so if you, and this is d of t. G, integrate this, 1 over 2 is 1 over 2. This integral will give you e power a minus s t divided by a minus s 0 to infinity and plus e power minus a plus s t divided by a plus s. इस माइनस को यहाँ पे शिफ्ट करें, this minus will give you, this will become minus, this will become minus, yes. So this is again 0 to infinity. So if you take s is greater than a, so again this will give you 1 over 2, 1 over a minus s, and minus 1 over a plus s. If you put this limit, ये क्लियर है जी?
Sir, जी s minus a.
By taking a minus s less than 0, you will get 1 over a minus s from this limit. Okay? जिस तरह इससे पहले क्वेश्चन में था,
Yes, sir.
Okay. ji. So if you take LCM, you will get 1 over 2. This will become a plus s minus a plus s divided by, sorry, this will become s minus a.
Yes, sir.
Yes, this will become s minus a. Due to lower limit, this will become s minus a. So this will become s square minus a square. नीचे अगर आप देख ले, s square minus a square, and this s, a will cancel with this a, and this will become 2s divided by 2. So this will become s divided by s square minus a square. So Laplace transform of cos hyperbolic at, this is a new formula, which is this one. Okay, ji. If you put here, instead of cos hyperbolic t, if you put sin hyperbolic at, this is another question. So this will become sin hyperbolic at, and this will become sin hyperbolic at, and this plus will become minus now. Is it clear?
Yes, sir.
Okay, this plus will become minus here. This minus will become plus here. This will become plus here, and now this will become plus g,
A minus S.
a plus s.
S minus A.
ये already plus था, sorry. ये already plus था. Now it will become minus. Now it will become minus. So this will become minus a plus a minus s. Now SS will cancel and AA will add. So this will become 2A. So this will become A divided by, so if this is sine hyperbolic, so this will become A divided by S square minus A square. So हमने दो फार्मूले और डेवलप कर लिए for what? For sine hyperbolic and cos hyperbolic. What are these formulas?
S divided by S square minus S.
जी, एक में देखिए, एक में ऊपर a होगा, दोनों में s स्क्वायर माइनस a स्क्वायर नीचे होंगे, एक में ये a होगा और दूसरे में s होगा, s स्क्वायर माइनस a स्क्वायर. इस साइन से स्टार्ट हो रहे हैं, लेकिन ये किसका होगा? ये साइन का होगा और ये कॉस का होगा. रिमेंबर दिस. Now if you take, this is sine omega t, मतलब साइन ट्राइग्नोमेट्रिक फंक्शन की मैं बात कर रहा हूँ, then find Laplace of f of t. If this is suppose sine omega t, not sine hyperbolic, if this is sine omega t, so So you will put here sine omega t. Now this is sine omega t. So this will become sine omega t. And if you integrate it once, so you will get what?
minus
G,
cos omega t divided by
e power minus st divided by minus s sine omega t as sine omega t. You apply the limit 0 to infinity minus 0 to infinity. You will write the derivative of sine omega t. First write the integral of e power minus st. This is e power minus st divided by minus s, and write the derivative of sine omega t. So this is omega cos omega t, and this is d of t. So if you put infinity, so e power minus infinity will become 0. Product में sin omega t भी खत्म हो जाएगा. If you put 0, so sin 0 is 0. So again this will give you 0. So ये term 0 हो जाएगा. This will become omega divided by s. So this will become omega divided by s. Omega divided by s, 0 to infinity, cos omega t e power minus st into d of t. So again integrate this, you will get omega by s. Again integrating by parts, so you will get e power minus st divided by minus s, and cos omega t is cos omega t. Again you put the limit 0 to infinity, then minus 0 to infinity. Now e power minus st divided by minus st divided by minus s, and the derivative of cos omega t is what? Minus omega sin omega t. into d of t, and एक बड़ा bracket भी लगा ले. So this will give you, if you put infinity, so this will give you 0. If you put 0, so omega cos omega t will become 1, cos 0 will become 1, and e power 0 will become 1. This minus will become plus, so omega by s. This will give you 1 over s. And this will become minus, minus, minus. This is minus omega by s. And the result is 0 to infinity. And this is actually the product of these two functions will give you, मैं एक step छोड़ के कर रहा हूँ. This will give you Laplace of sin omega t. Laplace of sin omega t. So you have started actually Laplace of sin omega t, and Laplace of sin omega t is appeared again. So you take it to the right hand side, to the left hand side. So if you shift it to the right, to the left hand side, so you will get the Laplace of sin omega t this minus will multiply with this minus plus, so this will become minus. So if you shift it to the right hand side, this will become omega square divided by s square, and this is Laplace of sine omega t. Sine omega t, and this is equal to, this is omega by s square. Omega by s square. So if you take common this Laplace of sine omega t from these two terms, this is omega by s square actually. This is omega by s square. So you will get 1 plus omega square s square, and Laplace of sine omega t, this is equal to omega by s square. So if you take LCM of these two functions, so this will become omega square plus s square divided by s square, if you remember. So if you take this into the right hand side, this is omega by s, I think. Note kare. Yes, this is omega by s. S square, yes. So this is Laplace of sine omega t, which is equal to, this s square will cancel with this s square, and a result you will obtain omega divided by omega square plus s square. So this is the Laplace transform of sine omega t. G. Is it clear? सिंपल कैलकुलेशन है, मुश्किल नहीं है, ठीक है जी। जिस तरह आप इंटीग्रल सॉल्व कर रहे थे, सो लेप्लास इज एक्चुअली ए फॉर्म ऑफ इंटीग्रल. So if you put this as cos omega t, this is your homework. If you put this cos omega t, so this will become cos omega t. So again you will perform the two integrals. जिस तरह हमने दो दफ़ा इंटीग्रेशन को रिपीट किया, सो एज ए रिजल्ट यू विल ऑब्टेन लेप्लास ऑफ साइन cos omega t. This will be equal to s divided by omega square plus s square. सेम प्रोसीजर अप्लाई करें, सो यू विल गेट द सेम रिजल्ट. थोड़ा सा डिफरेंस होगा, साइन में w होगा, इन cos देयर विल बी s, लेकिन इन डिनोमिनेटर देयर विल बी omega square plus s square and omega square plus s square in both the cases. So अब अगर हम फार्मूले लिख लें, तो हमने कितने फार्मूले डेवलप कर लिए, ये नोट करें. जी, first formula was for Laplace transform of second per third, fourth, fifth. This is second, sixth and seventh formula हमने develop कर लिए. First is for Laplace of a, which is a over s. Second was Laplace of t power n, which was n factorial divided by s power n plus 1. Third was Laplace of e power at. This was 1 over s minus a, and Laplace of cos hyperbolic at and Laplace of sine hyperbolic at. In sine hyperbolic and cos hyperbolic, there must be s square minus a square. There must be s square minus a square in denominator. But in sine, there will be a, in cos, there will be s. And what is the Laplace transform of cos omega t, and Laplace transform of sine omega t? In denominator, there must be s square plus omega square. S square plus omega square. But in sine, there must be omega, and cos, there must be s. याद हो गए फार्मूले जी?
Yes, sir.
ओके जी। तो असल में हमने लेप्लास ट्रांसफॉर्म अभी स्टार्ट किया है। सो जब हम डिफरेंशियल इक्वेशन पे इसको अप्लाई करेंगे, सो वी नीड दीज फार्मूलाज। सो हमें इन फार्मूलों की ज़रूरत पड़ेगी। सो देयरफॉर वी आर डिराइविंग दीज फार्मूलाज फ्रॉम बेसिक definition of Laplace. Now, if you have a Laplace transform, if you have an exponential function and any other function, cos hyperbolic at, suppose, cos hyperbolic at, yes, चले मैं एक सिंपल फंक्शन ले रहा हूँ t पावर स्क्वायर. So if the exponential function is multiplied with any other function जिसका हमने फार्मूले पढ़े हैं, अगर एक्सपोनेंशियल फंक्शन किसी भी फंक्शन के साथ मल्टीपल में आ जाए तो उसका लेप्लास ट्रांसफॉर्म ऐसे होगा. लेप्लास ट्रांसफॉर्म ऑफ टी स्क्वायर क्या था? इफ यू रिमेंबर जी.
2 factorial divided by s की power 1 plus 1.
जी, 2 फैक्टोरियल डिवाइडेड बाई एस क्यूब. तो ये कह रहे हैं कि एस जहां पे आ जाए उससे एस उसके साथ एस माइनस ए लिख ले, एस माइनस ए क्यूब ये लिख ले. ये एक्सपोनेंशियल फंक्शन का जो ए है कोएफिशिएंट, उस एस से उसको सब्ट्रैक्ट करके लिख ले. दिस इज कॉल्ड शिफ्टिंग थ्योरम. मैं दोबारा बता रहा हूं, लेप्लास ऑफ e power at, if you remember the Laplace sine, now if it is multiple with sine, so what is the Laplace transform of sine? So first write the Laplace transform of sine, which is omega divided by what? S square plus omega square. S square plus omega square. So remove this s square. जहां पे s square आ रहा हो या s आ रहा हो वहां पे s minus a लिख ले. So this will be s minus a square. Is it clear? So what will be the Laplace transform of e power at cos omega t? G. What is the Laplace of cos omega t? Which is s divided by s square plus omega square. ये था ना, खास का G. The Laplace transform
Yes, sir.
of class is this one, but you will write S minus A. जहाँ पे S हो वहाँ पे S minus A लिख ले, so this will become S minus A square. Is it clear now?
Yes, sir.
Okay.
Yes, sir.
Okay. So this is called shifting theorem. You apply the shifting theorem if a function is multiple with exponential function. So write the formula for the function and replace s by s minus a. So if you have e power 2t and the so what will be the Laplace transform of this function? Write the formula for t. What is the formula for t? 1 over s square. So this will become s minus 2 square. Is it clear? G. Replace s by s minus a. Now here a is 2. G. Is it clear?
Yes, sir. Clear.
Okay, G. So this is called a shifting theorem. So अब हमने सारे फार्मूले पढ़ लिए. ये एक फंक्शन नोट करें. If you have a Laplace transform of applied on this function a f of t plus b g of t, so how you will write this plus b g of t. So you can write this as Laplace of a f of t and plus Laplace of bg of t. Why you can apply the Laplace on the addition of two functions independently? Because Laplace is integral. And if integral is applied on the addition of two functions, suppose sine of x plus cos of x, so you can apply integral independently on sine and independently on cos. Apply कर सकते हैं ना? You can write at sine of x into d of x and plus integral of cos of x into d of x. You can write this G.
Yes, sir.
So Laplace is actually also a form of integral. So if it is applied on the addition of two functions, so you can apply it independently on each function. If there is a constant value, so you take common this constant value from a function, because Laplace is integral. If there is a constant value inside integral, so you can take common this constant value. So you can take common a constant value from Laplace because Laplace is integral. G. Is it clear? G. Okay, G. So I am writing some question. Suppose this is question number 1. Find Laplace transform of 2t square plus 3t plus 1. How to transform this function? So you can write it in this way. This is Laplace transform of 2t square You can write it Laplace transform of 2t square or 2t square, because you can apply Laplace independently on each function, plus Laplace of 3t plus Laplace of 1. You can also take common this 2 from Laplace, because Laplace is integral. If there is a constant value inside integral, so you can take common this constant value. So this is Laplace of t plus what? This is Laplace of 1. So what is the Laplace of T formula? That is 2 by 2 factorial means 2 by s cube, plus what is the Laplace transform of T? That is 1 over s square, if you remember. What is the Laplace transform of 1? That is 1 over s. So this is 4 by s cube plus 3 by s square plus 1 over s. So that is this function is actually the Laplace transform of this function, 2t square plus 3t plus 1. Is it clear?
Yes, sir.
Okay. So now you can find the Laplace transform of many functions. अगर question में आ जाए, find the Laplace transform of what? Laplace transform of suppose this is 2 e power 3t plus 2. Find the Laplace transform of this function. So you will apply Laplace on 2 e power 3t plus into plus Laplace transform of 2. So what is, you can take common this 2. So इसको common करें और बाकी Laplace of e power 3t क्या होगा? It will be 1 over s minus 3. What is the Laplace of 2? That is 2 by s. So this is actually the Laplace transform of what? This function, this function. Is it clear?
Yes, sir.
Okay. So now how to find the inverse Laplace transform? If you have a function, suppose this is f of s, f of s is equal to 1 over s square. Question is, find L inverse of f of s. Inverse Laplace transform. G, L inverse of f of s, both side apply L inverse. So you will get L inverse of 1 over s square. If you remember, the Laplace transform of t is 1 over s square. Laplace transform of t is 1 over s square. So the inverse Laplace transform of 1 over s square will be t. So this is t. Is it clear?
Yes, sir.
Okay, Ji. So if this is 1 over s cube, if this is 1 over s cube, so this will be 1 over s cube. Now what is the Laplace transform of 1 over s cube? You need first to multiply it with what? 2 factorial. So multiply and divide by 2. So you will obtain 2 by s cube. Now 1 over 2 अपनी जगह पे And what is the Laplace transform, inverse Laplace transform of this is t square actually. The Laplace transform of t square is 2 over s cube. So the L inverse of 2 over s cube will be t square. So the result is t square by 2. Is it clear now? G.
Yes, sir.
Yes,
Okay.
sir.
G. So if you इसमें जो मुश्किल चीज़ है वो मैं कर लेता हूँ, जो आपको मुश्किल लगेगा वो मैं कर लेता हूँ. सपोज एफ ऑफ एस इज व्हाट 1 ओवर एस स्क्वायर प्लस एस प्लस 3s plus 1. Find the inverse transform of this function. Find the inverse transform of this function. So you will apply L inverse on both sides f of s. So remember this. अभी तक हमने वो फार्मूला नहीं पढ़ा जिसमें s स्क्वायर प्लस s नीचे हो. हमने 7 फार्मूले पढ़े हैं, 8 फार्मूले पढ़े हैं. आप मुझे बता दें कि पहले 7 फार्मूलों में कभी s स्क्वायर प्लस s होता था?
No, sir.
डिनोमिनेटर में नहीं होता था ना. एस स्क्वायर माइनस ए स्क्वायर मैंने देखा था, एस स्क्वायर प्लस ए स्क्वायर मैंने देखा था, एस स्क्वायर सिर्फ एस स्क्वायर एस क्यूब मैंने देखा था, एस माइनस ए भी मैंने देखा था. लेकिन अगर आप देखें शिफ्टिंग फार्मूले में एस माइनस ए स्क्वायर नीचे होता था, इफ यू रिमेंबर.
Yes, sir.
सो इसको अगर ओपन करें, चले अब मैं इसको कर लेता हूं. 1 ओवर एस स्क्वायर प्लस 3s प्लस 1. सो दिस विल गिव यू L इनवर्स ऑफ. जब भी आप s स्क्वायर प्लस s देख ले, so you try to make completing square. So the method for completing square is s square की जगह s लिख ले, and you write the coefficient of s is 3, so you write 3 by 2. Divide the coefficient of s by 2 and take square of this. So you will get s square plus, then you write the plus 1, this one, and you write the minus of this 3 by 2. So this will become 9 by 4. ये बात क्लियर हो गई? This is completing square. So for completing square, if there is s square, you write s. If there is plus, you write plus. So divide the coefficient of s by 3 by 2. So you will write here 3 by 2. अगर यहाँ पे 1 हो तो आप 1 by 2 लिख ले. अगर यहाँ पे 3 हो 3 by 2 लिख ले. अगर यहाँ पे 5 हो, you write 5 by 2. And then subtract the square of 3 by 2. Square of 3 by 2 is 9 by 4. So subtract that from this constant value g.
Yes, sir.
Okay g. So you will write L inverse of 1 over s plus 3 by 2 square. What is 1 plus 9 by 4? This is 5 by 4. So you can write this 5 by 4 as square root 5 by 2 square. आप लिख सकते हैं इसे?
Minus, sir.
नहीं, yes, minus. Yes, this is minus. So लिख सकते हैं ना? So if you write this 2 by square root 5 here, L inverse, this is 5/2। मैं ओमेगा ऊपर बनाने लगा हूं, a 5/2, a is 5/2 in this case, divided by s plus 3/2 square minus 5/2 square। सो ये s माइनस a स्क्वायर फार्मूला नहीं है। So 2 by square root 5, what is the formula of this e power minus 3/2t? जी, ये किसका है, साइन का है या कास का, हाइपरबोलिक का है ना। जब s माइनस a स्क्वायर आप देख ले, so this is the hyperbolic formula. When there is constant in the numerator, so you will write sine hyperbolic. What is sine hyperbolic? What is a? A is square root 5/2 t। जी, ये क्लियर हुआ। what is exponent? This is s minus a। फार्मूले में ऐसे होता है ओमेगा a डिवाइडेड बाई s माइनस a स्क्वायर माइनस a स्क्वायर। सो ये माइनस a जो है, you can write this 3/2 as s minus minus 3/2, so a is minus 3/2। And what is a with hyperbolic? That is square root 5/2 g। Is that clear? जी, चले आप मुझे एक और बात बता देना, इसका लेप्लास ट्रांसफॉर्म क्या होगा, e पावर माइनस 3/2t साइन हाइपरबोलिक स्क्वायर रूट 5/2 t। What is the Laplace transform? So you will write the Laplace transform of sine. So what is the Laplace transform of sine? G, hyperbolic. This is a means square root 5/2 divided by g s square
minus
minus
a whole square,
minus
a square whole square।
g, and s से सब्ट्रैक्ट करेंगे क्या, s minus
minus
3/2 minus 3/2 स्क्वायर, ऐसे होगा।
yes
जी,
sir।
हेलो।
Yes, sir.
Yes, sir.
सो इसका इनवर्स ट्रांसफॉर्म फिर ये होगा ना।
Yes, sir.
ओके, सो नाउ इफ हियर इज s, सपोज अगर यहाँ पे s आ जाए, सो हियर विल बी s, हियर विल बी s g, हियर विल बी s। अब आपको क्या बनाने की जरूरत पड़ेगी, अगर ऊपर s आ जाए तो फिर तो ये चीज बनाना पड़ेगा ना।
Yes, sir.
सो प्लस 3/2 ऐड करना पड़ेगा, और -3/2 भी ऐड करना पड़ेगा। फिर इसको इसके नीचे अलग लेके लेप्लास ऑफ एल इनवर्स ऑफ s प्लस 3/2 divided by s plus 3/2 square minus square root 5/2 square and -3/2 L inverse of 1 over G. 1 over what?
S plus 3 divided by 2.
Yes, s plus 3 divided by 2 square minus square root 5/2 square. लेकिन जब ऊपर 1 आ जाए तो मुझे 5/2 बनाना पड़ेगा। 5/2 बनाने के लिए मैं 5/2 I am multiplying 2 by 5. So if you multiply 2 by 5, so this 2 will cancel with that 2 and you will get that is square root 5. Is it clear?
Yes, sir.
ओके जी। सो ये फार्मूला किस चीज का बनेगा?
cos hyperbolic.
दिस विल बी, ये देखिए ये किस चीज का बनेगा? ये तो ये होगा, साथ में -3/5 होगा, बट दिस फार्मूला इज देयर विल बी कॉज नाउ। जी, ये किस चीज का फार्मूला होगा? दिस विल बी e पावर -3/2 t cos hyperbolic, बिकॉज ऊपर s है, s minus a, cos hyperbolic square root 5/2 t and this one is -3/5 अपनी जगह पे, this is -3/5 and the remaining formula is e power -3/2 t and sin hyperbolic square root 5 by t, square root 5/2 and 2t. Is it clear now?
Yes, sir.
Okay, ji. So an exercise, the question are of these types. So exercise के questions मैंने भेजे हैं आपको।
Yes, sir.
So I will see that if there is homework which I don't send to you, so I will send it again. So see your stream and practice on these questions. So the before to shift to the solution of differential equation using Laplace transform, first you try the basics. So after, if you practice on these basics, then you will be able to handle the differential equation using the Laplace transform. Otherwise, you will not be able. So आप इस क्लास पे प्रैक्टिस करें। जब तक आप इस पे प्रैक्टिस नहीं करेंगे, मैं कुछ क्वेश्चंस भेज रहा हूँ, उस पे ज़रूर आप प्रैक्टिस करें। Without this, you will not be able to handle the differential equation, which we will study in the next class. So actual हमारा topic the solution of differential equation था using Laplace transform, but actually Laplace transform is a new topic. So first we have studied about the basics of Laplace transform, because without basics we cannot handle the differential equation using the Laplace transform. So in slides, this is the definition of Laplace transform. If you see, this is the inverse Laplace. This is the Laplace transform of 1. What will be the formula? That is 1 over s. ये already हम कर चुके हैं. This is the Laplace of transform of e power at. This is the Laplace transform when it is applied on the product of two, on the addition of two functions. So this is the Laplace transform of cos hyperbolic and sin hyperbolic. This is the Laplace transform of sin omega and cos omega. And this is a table which already we have derived these formulas. The Laplace transform of 1 is 1 over s, t is 1 over s square, t square is 2 over s cube, and all these Laplace transform of cos omega t is s by s. Already ये हम निकाल चुके हैं ये सारे. G. So the Laplace transform of t power n, this is shifting theorem, ये हम कर चुके हैं. So the Laplace transform of e power at cos omega t is s minus a square. Already we have done this. So up to page number 25, ये lecture हमने complete कर लिया. After this we will study it in next lecture. So 23 slide तक ये lecture हमने complete कर लिया. ठीक है जी?
Okay, sir. Sir, we can't watch lecture 8 video.
Lecture 8 video. So
Yes.
I think I have shared it with you.
Yeah, you shared with us, but if I click it, then it displays me take a permission from the teacher like that.
Okay, I will send it again. I will try to search that video and I will send it again. Okay, जी?
Okay, sir. Thank
सर
you.
फाइनल टर्म एग्जाम ऑनलाइन होगी क्या ऑफलाइन?
एग्जाम जी 24 of August से स्टार्ट हो रहे हैं. ठीक है जी? If you have schedule with you, so हमारे साथ जो schedule शेयर हुआ है, so exam is starting from 24th of August. So
सर
I
वो तो
think
प्रेस स्टार्ट नहीं होगी,
जी
तो प्रेस नहीं स्टार्ट होंगे 24 अगस्त से. पेपर तो मेरे ख्याल में 7 सितंबर से हैं.
नहीं, अभी जो नए शेड्यूल आया है कल परसों आया है, सो उसके मुताबिक 24 से एग्जाम स्टार्ट हो रहे हैं. There is
Sir,
no preparation week.
is it online?
Yes, it will be online, but there is no preparation week, no makeup class week, I think. So you asked from your coordinator, it will be better. But as I am concerned, so
ठीक है सर.
the schedule which is
सर
shared with me is exam is started from 24th of August. So there is no, I think, no preparation week and no rescheduled class week. Okay जी?
Okay,
So
sir.
इसके
Thank you.
उसके मुताबिक 3 वीक्स रहते हैं.
सर हमें तो शेड्यूल नहीं मिला है.
शेड्यूल आप कोऑर्डिनेटर साहब से बात कर ले. सो आई थिंक ही विल शेयर दैट विद यू. मे बी सिविल का